Hello friends, today we'll try to solve this question, Leetcode 20, valid parenthesis. Uh, you might have heard about this question a lot. It's a famous interview question, and usually during off-campus placements, this type of question is generally asked in the first round itself. Uh, if you're lucky enough, you might get this question in the third round as well, but as it's a simple question, it's generally asked in the first round. And it's frequently asked question. So we'll deep dive into the question and understand what this question is really about. And basically, this question tells us how to use the stack data structure, right? So basically, what is a valid parenthesis? We have in school during ninth and 10th class, while writing algebraic equations, we generally use these type of brackets: open brackets, close brackets, and curly brackets. Or we can also call it curly braces as well, right? So for writing inequalities, we generally use these kind of brackets, right? Suppose suppose if x has if x contains let's say seven values, right? And those seven values are 4, 5, 6, 7, 8, 9, and 10, right? So using these brackets, we could basically tell whether how to write these values, right? So for example, when we use these brackets, right? So we can simply say x belongs to 3 comma 11, right? When we are using square brackets, we could write it as, sorry for my writing, uh, we could write it as x belongs to 4 comma 10, right? And when we are using curly braces, we just have to write like this: x belongs to 4, 5, and basically all these values up to 10. All right, so this is how we use these brackets, but this is not the part of the question, and we just have to tell whether what constitutes as a valid parenthesis, right? So the basic thing is that the first rule, which is given in the question also, is that if there is an open bracket, right, like this, then it must be closed by the same type of bracket, like this. You cannot close an open bracket of this type with a square bracket, right? And at at the same time, the first rule is this, and at the same time, the second rule would be if there is an open bracket, right, then it must be closed in the correct order. For example, if I write it like this, right? So it must be closed. Like for this particular bracket, we have to write a closed bracket. For this, we have to write this, and for this, we have to write this again, right? And every closed bracket should be of the same type of the corresponding open bracket. All right. So how do we solve it, right? For example, let's say I have this expression. I have an open bracket here. There is again an open bracket. I closed it, and that's it. Will it be a valid parenthesis? By logic, I opened a bracket. I again use an open bracket. I again use an open bracket. But for this open bracket, I used close bracket, this one. And for this, I close it again. But what about this? I don't have it. I don't have a close bracket for this particular open bracket. So it's not valid, right? So by looking with the naked eye, you can simply say whether it's an open bracket or not. But how would you tell using a code, right? So for this, we'll be using stack data structure. Stack basically works on a simple principle which we call as LIFO, that is last in, first out. Alright, so last in, first out. What does this mean? Basically, we can visualize stack like a bucket, right? So if we add a value 1 here and then we add a value 2, then we add a value 3, right? Now we want to remove elements from the stack. So we can remove only that element from the stack which was added last, right? So first one was added, second two was added, and last three was added. So when we remove the value, we remove it from the top of the stack, and top of the stack is 3. So when we remove it, stack becomes 1 and 2, right? So this is the basic principle of last and first out, right? So basically, so if we add, let's say we have three numbers A, B, and C. The order of adding the values in stack is A, B, and C. Then if we remove the elements from the stack, the order that we'll get is C, B, and A. Last one was C, second last one was B, and then A. So this will be the order of deletion, and this will be order of addition. Alright, now how to use stack in solving this question, right? So let's see, our example was this. Alright, so let's say we have a stack here. We have a variable current character and we have the top of the stack, right? Now what to do? Now when we encounter an open bracket, we have to do nothing. We will just push it in the stack. So the first element is this, right? It's an open bracket. We'll just push it in the stack. The next element is this. Again, we push it in the stack. The next element is this. We'll push it in the stack as well. Now we come across this element, right? So the current character is this and the top of the stack is this. Are they of the same type? Yes, they are. So when this happens, we'll simply pop. Alright, so what we'll do is that we'll pop and this becomes this. Now let's go to the next step. Now the next element is this and top of the stack is this. Are those the same type? Yes, they are. So again, we'll pop. So when we pop it, it becomes this, right? Now, major thing is that we have traversed through all the characters, right? And now we are left with one bracket in the stack, and which is an open bracket. Now we don't have any other bracket which compensates for this open bracket, right? That means the parenthesis is not valid. So the stack is not empty, therefore not valid, right? Now let's look at a different example. This time let's write it like this. We have this this and then we have a square bracket, a closed one, this and this. Alright, so let's go ahead. First character, this. Fair enough. We'll write it, we'll push it in the stack. The second character, it's an open bracket. This is also open, so we'll go with the open one. Now, the next element, it's an open bracket, it's a closed bracket, right? So current element is this, top of the stack is this. Both are of same type, that means we can pop, right? Fair enough, we popped. Now, the next element is this. Next element is our closed square bracket, and top of the element is, top of the stack is this. They both are of same type, we can pop again, right? So let's pop it and we removed it, right? The next element, the last element, it's close curly brace, top of the stack is this, both are of same type, we pop the element, right? We have traversed through the whole string expression and finally the stack is empty. Now stack doesn't contain any open bracket, we have traversed through all the elements present in the string, so this should be a valid expression, right? So ultimately it's a valid expression, so we'll return true. Okay, now let's consider a different example. Let's say we have a curly brace here, we have an open bracket here, and let's close it and go ahead again like this, right? Again we encounter an open bracket here. Let's put that in the stack. Again an open bracket, put it again, then again simply put it. Now we encounter an open bracket. Current character is this, top of the stack is this. So for an open square bracket we have this closed bracket. They are not of the same type. So simply we can say that they both don't have, they are, that this expression is not valid as the particular open bracket and the closed bracket are not of the same type. So simply we'll return a false, right? Now let's think about a different situation. What if we write an expression like this? We have here, we have this whole expression. Now check, we'll check whether it's correct or not, right? So let's remove the cases here. So see, first three elements are open brackets, so we'll just push them as it is. Alright, now we come across this bracket, right? Top of the element is this, they are of the same type, we'll remove it, right? At the same time, for this bracket, we have the same case here, and top of the stack is this, we will remove it, right? Again, we encounter the same case for the next character, and we'll pop it again, right? In the next case, for the final element in the character, array or string, uh, we can simply think the current character will be a close bracket, but the top of element is not, top of the stack is not there because stack is empty. So ultimately there is no open bracket which can compensate this close bracket or balance out this close bracket. So ultimately it's not correct, right? So so this is not valid, right? So we'll return a false. Sorry for my handwriting. So it will return a false. So I hope you are getting what I'm trying to say here, right? So we'll try to code it. So let's try to solve this question. So in Java, how do we declare an object of stack, right? So we have an inbuilt stack function in stack class in Java. So this is how we are going to make the stack. We are using a stack of character type, right? So stack, and okay, we have created the stack. Now we'll just go one by one for every character of the string. So what we can do is that we can use a for loop and check each character present in the string, right? So for that we first have to calculate the length of the string, and we will use the function of char of string to check whether that particular character at that string is valid or not. But instead of that, what we can do is that we can use another method of string which is known as to char a array, right? What it simply does is, if we have a string abc, right? So when we apply this method on this string, it will convert it into an array of characters. So it has 3 characters currently, a, b, and c. So it will make it like this. Okay, so we'll just create this array and apply for each loop on that. So what I'm going to do, I need a character array, and I'll convert the string into character using this method, right? So what's our first case? First case, if we encounter any open bracket. So we have 3 types of open bracket. So it can be of this type, or it can be of this type, or it can be this type, right? And if we encounter a square bracket, all we have to do is that we have to push that element in the stack, right? Simple. So this is our first case. And if that's not the case, then what we have to do? So in the last case, we saw that if we encounter a close bracket and stack is empty, right? That means we don't have an open bracket to balance out that close bracket. So simply we'll just write if stack is empty, right? We'll return a false. Fair enough. Now what we're going to do is that we'll just fetch the top of the element of stack, which would be this, right? Sorry. Alright. Now, what we have to check is that if the character is this of closed type, right? And the top of the element is not equal to this, right? Will return a false, isn't it? So ultimately, if our closed bracket is of type this, the open bracket must be of type this, right? So this is our first case, and the same we are going to apply in the next part as well. So the condition is this time if it's of type square bracket and top is not of like this, top is not like this, and then we encounter curly brace and it should be like this. So I hope it's looking fine, right? So we'll simply, in such case, we'll simply return a false. And alright, fair enough. So we have got the code here. We have completed the code. Now, when we come out of the loop, right? Suppose we have traveled the loop and everything has happened. Now, how to check whether it's valid or not? So, in the second case, where we checked when we traversed through the whole string and we found that stack is empty, right? Then we got to know that the parenthesis is valid, right? So after traversing through the character array, if the stack is empty, then the expression should be a valid expression, right? And if there is an element present in the stack, that means there is no closed bracket in that expression that may balance out the stack. That means if after traversing through the whole character array, if stack is empty, that means the expression is valid. And if stack is not empty, that means expression is not valid. So we'll simply return whether the stack is empty or not, and we'll be done. Let's try to run it. So there is a compilation error. Let's check what's the error. Alright, we didn't put an equal to sign here. Let's see if it works this time. And yeah, let's try to submit it. And indeed, we are able to solve this question. So it's a simple question. I think you all have got it properly. And yeah, I took a lot of time to explain it. Sorry on my part. I'm just trying to, improve upon my communication skills. And in the future, I hope I'll be able to improve and get some better content. So if you like it, that's really good news for me. And if you don't, then just cooperate with me and show me that I'll improve. So thanks for watching, and I hope that you all understood the solution properly. And it's a good question, and there are many other questions as well. There is one variation of this question where there are elements like characters like a, b, c, plus, minus, and everything. So you can, try to solve that part as well. So let's meet in the next video. So thanks.